Good morning, one and all. Now, today we are going to start with a fresh unit, that is a power flow analysis or load flow analysis. So, power flow analysis or load flow analysis is one of the basic tools in the power system studies. So, it is concerned with the steady state analysis of system when it is working under normal balance operation condition. This load flow or power flow analysis, the determination of voltage, current, real power, reactive power at various points in the electric network. Okay, say for example, a single line diagram is there with the generator, with the transmission line and some loads or some thing. Okay, so you need to determine the voltage, current, PQ. P means real power, Q means reactive power. So in the various points. So generator bus, what is these values? Okay, transmission bus, what is the values? Okay, like load bus, what is the value? Like that, we need to determine at various points in the electric network so that we can understand whether the power flow is happening correctly or not. And it is, and also it is working under normal balance operation condition or any losses is there. Like that, many things we can find out by using this power flow analysis or this load flow analysis. Okay, what is the significance of load flow analysis? The main significance of load flow analysis, the information of load flow analysis is essential for analyzing the effective alternative plans for the system expansion to meet the increasing load demand. Say, for example, in the generator bus, you are sending 1500 megawatt. In the load bus, you are receiving, say, for example, 1480 megawatt. Okay, 1480 megawatt, but generation it is 1500 megawatt. So what is the deficit of 20 megawatt? Because 1500 minus 1480. So 20 megawatt is the deficit, power deficit. So 20 megawatt is the power deficit means. So we need to plan, say for example, that 20 megawatt, say for example, your load is 1500 megawatt, but the generation is also 1500 megawatt. But receiving station only we are getting 1480 megawatt. So 20 megawatt deficit. So definitely we need to increase the generation. So generally they will not do, say for example, if the load is 1300 megawatt or 1400 megawatt, they will send 1500 megawatt because transmission loss is there. 15 to 20% transmission loss there. So plus or minus only they will generate. Okay. So you say, for example, load is 1450 megawatt. So they will send the generating station, they will send 1500 megawatt because load might be varying like anything. Okay. Say, for example, summer season, if you take in the morning peak hours. So like morning peak hours itself, okay, due to hot sun, due to the climatic changes. So it is very the temperature is like anything throughout the world. Throughout the world countries, summer, if you take, the temperature is increasing like anything because we can't get to the rainy season, rain at the correct season. And that time also, one or two places heavily floated. If you take like countries like India, then England, okay, then some US, some parts, rainfall is it rained in the different seasons. Okay, so we are expecting rain for one whole week, but the whole week rain it's rained in only 1 day or 2 days. Okay, so the whole city gets floated. See, in India, the cities like Chennai, Mumbai. Okay, next if you take UK, London, and if you take parts of United States also floated like anything, and Canada also floated. So why? Because it okay happened in only 1 day. Okay, so some 25 centimeter, 40 centimeters of rain, 50 centimeters of rain, rained in only 1 day. See, that rain has to come for even a month. Okay, that everything rained in 1 or 2 days itself. So every places were floated like anything. So due to that, okay, due to that, say for example, there is no water in the hydropower station, no water in the hydropower station. So due to increasing load demand, okay, so this the load demand can't be managed. Demand can't be managed. So what we are doing is we are using the generators in some offices, in some industries. We are using the generators for some hours, some 1 hour or 2 hours. We have to use because due to the power deficit, no correct reliable power is coming. No reliable power because water is also not there. So somehow they are managing generating companies they are managing. So due to the increase in the load demand, so by testing this all these values, say for example, I said no voltage, current, real power, reactive power. Change in the what is the change in the voltage? What is the change in the real power? What is the change in the reactive power? So easily we can get managed load demand these parameters. So load flow analysis very necessary. Next, load flow studies are very important for planning, economic scheduling. Planning means, say for example, if you are going for extension, so the load is increasing like anything in a particular area. So we are going for extension. So when we need to go for extension means previously 5 years before itself, you need to plan for this extension because then only somehow you can manage that power generation from any hydropower station or thermal power station. You need to increase the size of size of the hydropower station. You need to increase the size of the thermal power station. Then only the extension planning is possible. Next, economical scheduling, economic scheduling. So we need to do correct scheduling, economic scheduling of the generation. Okay, so we need to choose the low cost generators, always low cost generators like hydropower, then power generation from renewable energy resources, so that our cost also will be reduced. Next, control and operations of existing system as well as planning in future expansion depends on the effect of interconnection. Okay, effect of interconnection, new loads, new generating station and all. Okay, so we need to plan the interconnection like distribution lines. Okay, say for example, 11 kilovolts line is there. So if more industries are coming that particular area, you need to just extend that transmission line to some 33 kilovolt or 66 kilovolt, depends on the load. Okay, so like that we need to plan for the new interconnection. Next is a new generation station, as I said, a new transmission lines also, and new loads. Loads, we can't stay new loads. Loads may be increasing or decreasing like anything. Sometimes it depends on the usage, it depends on the climatic condition, summer season or winter season, autumn season, depends on the climatic condition. So we need to forecast the load. That is our power system engineers who are working in the generating station. We need to plan for the extension, and with the help of this load flow studies, we can determine the best size as well as most favorable location of the power system capacitors, both for improvement of power factor and raising the bus voltage in the electrical network. Say for example, if it is in near to industrial areas. Okay, so more this what do you call inductive loads, more inductive loads. Due to the more inductive loads, the power factor also reducing like anything. But power factor, they will see the power factor in the meters itself. Now, due to modern electronic meters, so power factor everywhere they are monitoring the power factor. So if power factor they are maintaining less than 0.9. Okay, they will be given with the penalty factor. So they need to maintain the power factors 0.99 or 1. Okay, so sometimes 1 or many times 0.99 or 98 like that. It might be wavering. But the industries, especially to industries, they need to maintain the power factor as a constant. Otherwise, they will be punished with a penalty factor tariff. Penalty factor tariff. Say, for example, one company, a small scale industry turnover is some 10 lakhs. If they are not maintaining this power factor constant, okay, so at the end of 1 month, what they will do, the reading people, okay, so will come to the home or will come to that particular industry. They will test all the power factor. They will test all the how the load is being utilized, like that. They will test. Okay, so if the power factor they not maintain as per the standards of the particular okay country or not country throughout the world, it is the power factor you need to maintain as 1.9921. Okay, 0.99921. So the tolerance limit is 0.0001 like this. So that may happen because no system is a constant. No system you can't. No system is ideal. Okay, you can't say because due to some variations in the load, it may come to 0.99 or 0.98, but that is the tolerance limit. But if you go below that value, definitely you will be imposed with the power factor tariff. Okay, so so that particular company, as I said, instead of their turnover itself 10 lakhs. So if they not maintaining that power factor for many times in that particular month, so they need to impose the power factor tariff. Say, for example, they are paying power factor tariff as like 50,000. Okay, so loss is, you see the loss. Okay, their profit is from the 10 lakhs turnover. Their profit is, say, for example, 3 lakhs is their profit. If they pay 50,000, okay, so definitely that will be the huge loss for that particular company. Okay, so definitely if they pay 50,000, definitely that electrical supervisor in that particular company has to lose his job because they are paying because the profit itself 3 lakhs. Okay, then they paid 50,000 means that is that cost is more. So definitely you need to maintain this power factor as a constant. Okay, so problems such as optimization of the system loss, stability check, general security of the system can be studied with the help of this load flow studies. Next, the information obtained from the load flow studies are the magnitude and phase angle of the voltage at each bus. Okay, say for example, active power, reactive power flow, the each line, and the power loss also in the line. So what is the power loss? As I said, 1500 megawatt, 1480 megawatt. So what is the power loss? 20 megawatt is the power loss. Like that, you need to calculate. So it gives the initial condition of the system when transient behavior of the system also should be studied, to be studied. Okay, so the mathematical formulation of the load flow problem results in the system of non-linear equation. These equation can be written terms of the bus admittance matrix or bus impedance matrix. That's what we study, how to calculate the bus admittance matrix, how to calculate the bus impedance matrix. Using this bus admittance matrix is amenable to the digital computer analysis because you can't do, say, for example, some 4 bus you can do. Okay, so with your pen and paper. Okay, but that too with the real values, real power system values, I think it is more complex. Okay, like more than 4 buses means definitely you can't do with your pen and paper. Definitely you have to go for this computer computer analysis, pre-programmed analysis. Just you need to tell the computer program you need to design. That's just you need to tell how many buses are there. Say for example, 40 bus. So what is the 40 bus? What is the impedance value between the each bus? So that data, if you just upload in that particular program, automatically within some seconds or minutes, like maximum 60 seconds to 1 minute or maximum 2 minutes, you will get all the answer. Okay, with this computer analysis. Okay, so that makes our job simple, power system engineers job simple, so that also time taken for solving also simple. Say for example, that 40 bus if you solve with pen and paper, definitely it might take okay, more than a day, 24 hours also. That to correct answer, like precise answer you get or not, that is also a doubtful man. So if you solve with pen and paper, it will take more time. So the computation time for analysis of that particular problem should be very, very less so that you get the answers quickly. Okay, so that you need to, this point you need to stress on what is the significance. Next step, the load flow analysis can be carried out for the small, medium size power station. It shoots for radial distribution system with a high RX ratio. Okay, small and medium sized power station shoots for radial distribution system with resistance and impedance, high resistance and impedance ratio. Next, load flow analysis helps to identify the overloaded or underloaded lines. Okay, so you can easily check which bus is overloaded, which bus is underloaded, and which transformer is as over voltage, which transformer has under voltage buses in the system. Like that, you can easily identify by using this load flow analysis. Next, it is used to, sorry, it is used to, yeah, it is used to study the optimum location of capacitor and their size to improve the unacceptable voltage power. So the power factor reduce means in the companies, what they will do, the industries, they will go for the capacitor bands. Okay, they will inject the capacitor band so that so the lagging power factor they will make the lagging power factor to leading. Okay, so that the power factor also they will be maintaining constant. So say for example, the hard case in one company is not maintaining the power factor as a constant one. So definitely that will reflect in your substation, nearby substation, whichever that particular industries is being connected. So what they will do, simply they will wait for 2 minutes. Okay, so if not, they will just to open that feeder. Feeder means whichever that particular industry is connected with that feeder, simply open that feeder because all the things, all the substations are connected to the state grid. Substations are connected to the local grid and to the state grid. State grid is connected to the national grid. Okay, so if they are not maintaining means you'll get the call from state grid. State grid is connected to regional grid. Okay, regional grid that will okay, one day we'll see correctly. Okay, that particular grid formation. What are the advantages of the grid formation and how they are forming the grid in India? Okay, what are the advantages in framing the grid, why the grid is necessary, what are all the parameters they are maintaining, and they are recording in that particular grid station in regional grid and as well as state grid or national grid. So that we'll see one class separately. Now, so optimum location of capacitor also necessary to improve this unacceptable voltage profile. Next, coming to the need for load flow analysis, or importance of load flow analysis in planning and operation of the power system. So load flow analysis performed under symmetrical steady state operating condition of the power system under normal mode of the operation, normal mode of operation. The solution to load flow gives the bus voltage, line, transformer power flows for a given load condition. This information is essential for long-term planning and operational planning. So what is long-term planning? Long-term planning is nothing but load flow analysis help in investigating the effectiveness of alternative plans and choosing the best plan for the power system expansion to meet the projected operating state. So what is the main aim for this long-term planning means? This helps in investigating the effectiveness of alternative plans. So what are the alternative plans that we should make so that the system is optimal, or the system optimal means the system will meet the demand, how the system should meet the demand, and what is the best plan for system expansion. Okay, for the projected operating state, some operating states you are taking. So what is the best plan, like that we can easily understand. Next is operational planning. Operation planning is nothing but it helps in choosing the best unit commitment plan. What is the unit commitment? What is meant by unit commitment? Unit commitment is nothing but committing the generating units as per the demand, as per the demand. Okay, and also with the losses. Okay, committing the generating units. So, say for example, you are having 40 generating units in your hand. This is the load. Okay, so best generating units you need to commit, because least generating units, best generating units nothing but least generating units you should commit, so that you can meet out the demand. So if you not okay, choose the least cost generating unit, automatically the cost of the generation is increased. So automatically who will be the bearer? We are the bearer. The consumers are the bearer. If the generating cost goes high, okay, definitely what they will do, they will add in our head only, because we are the consumers. So consumers only, they will say, for example, they will tell this is the summer month, so the load is also more, and we need to purchase the load, purchase the power for the more price. So definitely what they will do, they will increase the tariff to the consumers. So you need to select the least cost generator, so that the cost of the tariff cost that which we are consuming, that also will be reduced. Next, unit commitment and generation schedules. I said no, generation economic scheduling of the generating station. Okay, economic. So if not, you just go back to my previous videos and just study about this economic generation schedules. There I have explained in the detailed manner in the economic generation playlist. So you can see, so that you can understand this very easy. Okay, economic generation schedules to run the system efficiently for the next day load condition without violating the bus voltage and the line flow operating limits. So without violating this bus voltage and line flow operating limits, so you need to run this all this generating station, and also you need to schedule. Say for a schedule means, say for example 24 hours period of time, 24 hours period of time. So say for example this hydro you need to utilize for 18 hours, and thermal generating you need to utilize for 6 hours, and some other renewable generating you need to utilize for 12 hours. Like that you need to schedule the generating station, so that for the next day. Next day you need to schedule. Okay, so approximately next day schedule, because today's load, if you monitor how the today's load is varying, and what is the previous year, the same load will be. So if you compare approximately, you'll know. So based on that, you need to generate and you need to schedule, commit the generating unit, and you need to schedule the particular generating station, so that there will be not any interruption. Next, what are the steps for load flow study? What are the steps for load flow? First, we need to represent that power system by using single line diagram. In the problems, when solving the problems, mostly, okay, they will be mentioning all this with the single line diagram. If not single line diagram, they will be giving the values for the bus. Say for example, bus 1 to 2, what is the impedance? Okay, bus 2 to 3, what is the impedance? 3 to 4, like that. They will be mentioning the impedance. You need to frame the single line diagram from the data. Okay, so that is the first step. Next is determining the impedance diagram with the using the information in the single line diagram. As I said, so you need to specify the impedance. Okay, impedance from that diagram, or from the given values, from the problem. Next, the formulation of the network equation, formulation of the network equation, and solution to the network equation. So these are the steps that followed for the load flow studies. In the 2 marks, they will be asking this. So write the steps to follow the load flow studies, like that also they may ask. And here also 2 marks, they will, what is the need for node flow analysis? This is the one of the 2 mark question.